We should have
We're going to
done that right away.
plan to talk, prepare the talk, prepare to talk, and then perform the talk. This is a performance. It's plain and simple. Now, preparing to present virtually, you have to look at lighting and shadows and what are you wearing and where should you be. So I took a couple of pictures of myself, make sure there's not lines in the from the blinds or you're behind a really bright window. So find the place, find the clothes, and what is your background going to be? Believe it or not, that was a shelving unit in my grandchildren's room. I didn't sit in front of that. And then there's a plain wall or some furniture. Does it reflect light? That kind of thing. So you look directly into your camera and chin up. Hard for us older people to do sometimes. So then know when and where and how long you have. And that's really important. I know for us, we've sent out the schedules already. You know when it's going to be, how long you have, and how long you're supposed to talk for. I just did a fair for Science and Engineering County Fair for North Carolina virtually, and the students were told to talk for 4 minutes. Some of them talked for like 8 or 9 minutes. We only had 11 minutes with them. We had to stop them. And if you have to be stopped, you might not get to your most important main message because you're supposed to inform, persuade, and entertain, engage your audience. Sometimes you use hands. Hands still work virtually. I think you can see my hands. I can't see myself right now. So keep those things in mind that you're going to be looking at somebody, but if you don't pay attention to what your time limits are, you will mess up. So you need to know exactly how much time you have. And then so if you have these time limits, how much should you cover? And you need to be clear and you need to be brief and concise. Remember that the audience is listening and not reading, and you need to be enthusiastic, like they will be engaged if you're engaged. If you're reading, usually in science, we don't read, we have notes to go by. It's important to say, these are the important points I want to cover and have those maybe in your slide, but you don't want to read it because reading really, it gets a little dry. Some subjects you do read. I was surprised by that when I changed fields later in my career, but you want to keep it simple and straight to the point. And one way to do that is to prepare the talk and make each point clearly to tie to the audience and to keep your visuals really simple. You want to also tie to your main message. So if everything goes to the main message, you need to give a little bit of background, but we don't need every single step that you have. You've written that out. You've put that somewhere else, but you don't need to go through. I put 20 liters into this bottle and then I microwaved it for 45 seconds. That's in the paper. That can be on the poster board. But when you're speaking, assume that the person, well, they will have read your abstract. They kind of know what you're doing. If it's a completely new technology, maybe you have to go over that. But you want to keep it simple and you want to use a lot of graphics, impromptu notes, memorize. And we'll get to it a little bit later. What do you have to do to memorize your talk? Also, tell a story. The best parts about your research is make it yours. We know that you either went to a lab and you read a lot of books, but what made you interested in this? Why is it a story? Hey, when I was walking down the street, I remember this young lady saying, I saw these things all over the ground when I was visiting my grandmother in India. And then I picked them up and said, "What are these?" And the grandmother said, "Oh, we grind that up and that seems to keep UTIs away. So we make tea with that." And she said, "I wonder if it really works. I wonder if I can set up an experiment to test that." So that was her story. Now, if she just started, "I'm going to test my, you know, this problem against cinnamon," and didn't tell that story at the beginning, then it wouldn't feel like her story. So make sure to add those things to your talk, that it is a story. I had an advisor once that said, you're not ready to publish yet till you have a story to tell. So we want to hear your story. We also want you to focus on what is your main message. What is it that you want them to take back? Does everything you say tie back to the main message? And does it matter? How can you make it matter? And you can make it matter with a value statement. Either you made something that's safer or cheaper or is going to help people with cancer. It may be just a little part, but if you don't link it back, if you just say, "I made these really cool polymers that come out and they're stretchy and they're bendable and they absorb things and they're biodegradable. Isn't that great?" You need to bring that back. "Oh, by the way, those are to be put inside a human body so that bones can grow on them." Then it becomes interesting. Everybody knows somebody that broke something and had to have something put in. So your value statement about why is this better? Why is this good for the science? When I used to do provost awards for professors and staff members at the university, part of it was we measured and we looked at, did what this person do give back to their science or to the world or to society? How did it help other people? And that's a really important thing to know. And that's why JSHS, having that human side, why does it matter? That needs to be part of your talk. That needs to be part of your main message. We're doing this to make things cheaper, to clean the environment, to help people diagnose something quicker. We made this engine or this mechanical project to make life better for humanity. Okay. Also, this is really, really important. And that's why we wanted everybody here to say practice and perform. You need to practice what you're going to say and you need to perform it in front of an audience. I don't care if it's your stuffed animals, if it's, your family first to start out with, a bigger group. Maybe it's a little easier with a computer, but I think it might be a little trickier because you're not seeing the people and you're not seeing the big audience. But you need to practice. Practice doesn't make perfect, but can practicing correctly with an audience and getting feedback, that's really important. Okay, that's important. And also at the end, when you get questions, I work with a lot of judges across the country. I'm in Michigan right now. They're having their JSHS the 25th, so it's coming up real quick. Um, the uh, question time is when judges say, this is when we really find out, does the student know their stuff? Or did they just memorize a talk? Were they just told what to do? This is why you need to make it your own. So when someone asks a question, repeat the question. That helps you to A, make sure that you understood what they're asking you, and B, make sure that you have a little time to process, what am I going to say? And you should stay in known territory. Don't say, "I think that this might be the answer," or "I think that that might be the answer." That's okay to say that. But when you say, "This is the definite answer and I have solved the problem of cancer," that's really overstating probably what you've done. And there will be some experts and some novices in your judging panel. And so that's why being respectful to the person who asks the question and staying in known territory. You can, and a lot of times the judges want you to think. You can say, well, that wasn't, don't just say, that was not a part of my research. Because if you just say it wasn't part of my research, end there, you can say it wasn't part of my research. But if I were to, based on what I've done, I think that this might be what happens. That's really staying in your area. And this next slide, and this is because we're trying to be brief, when you do your evaluation at the end, one of the things, we got mixed messages. First year we said we wish we had more time to do our part, our presenting part. And then the next year they said, you went so fast, I didn't get everything. But we are recording this. You will be able to ask questions of myself, of Dr. LaBanca, of Dr. Knight, after this, and even some of the other people that are here. They're here to be resources to you. But I'm leaving this up because it will be up in the recording for a little bit. Here's some other experts. Now that we have the internet, how to give a good talk is out there. And there's practice sites. There's a lot of information out there. And you have everything else in the information that we give you or that Dr. LaBanca gives you for when, where, what time, those kinds of things. And I'm going to end this here, and I'm going to stop sharing. And I think in my chats, it's just not so much questions, but comments and ideas that Patriot Clark Duffner put down. So check out the chats while we're moving from one thing to another, and there will be a lot of the points that I have made. She wrote them again. So I'm going to stop sharing my video and stop. There it goes. No, that was video. Stop sharing. How do I stop sharing? I think it says right here, stop sharing. There we go. I'm going to get this thing yet. There we go. Okay. Dr. LaBanca, can you let him share? Oh, there we go.
We're already there. Thank you. Thank you, Mrs. Erickson. It's great to see everyone today. We're really excited to share with you. I think, I was trying to think, Joy, how long have we been doing this workshop together? I know we did a virtual recording in 2013, and that's after having done it for a number of years. So we've probably been at this 15, 20 years or so.
At least 15 years, I think. The first ones were done down in New Haven. Jim Boker, was he the person who, oh no, I can't remember, but the new Adult Education Center in New Haven, that's where we started doing them, because that we wanted to pull from other places, but we've done this in many places over the years. So similar workshops, but this is probably our biggest group of students virtually that we've ever had. And I'm really
exciting. My first JSHS was 1997. So
my first was 1994. So there you go.
Been at it a long time, and I think we both find that both the JSHS and the CSEF give students such an excellent opportunity to showcase original work, and that's really why we're here to help you to present that. I'm going to do a shameless plug before we go on. Tomorrow morning on 1080, I'm going to be on the News You Can Use show talking about the Connecticut Science and Engineering Fair. So if you want to hear some more about the history and what we're up to this year, please shamelessly join me either at 5:30 a.m. I don't know if anyone's joining me for that one, but at 9 a.m. as well. News You Can Use on 1080 to hear about the Connecticut Science and Engineering Fair.
Frank, could I just interrupt for a moment?
Sure,
is your camera off intentionally? Okay.
Sorry.
Thank you.
Okay, there we go. So sorry about that, everyone. So I'm going to reiterate what Joy was talking about, planning, preparing, and presenting. It's so important. And even when you're talking about the use of visual aids in the process, those have to be planned and prepared, and you have to know their locations. Since the Connecticut Science and Engineering Fair is virtual, we have some flexibility in how you can present your work as well. So the things we're going to talk about here are really about not only creating PowerPoints, but also how to create posters at the same time. How should things look when you create them? And I have some very purposeful things I do when I create presentations, and I'm going to share some of them with you so you can use them as food for thought as well. We have a little activity we'll do during the process as well. I do always take a few minutes to talk about academic honesty and responsibility in the process, because there are certain traps that students can fall into, and we wouldn't want anyone to fall into a trap that could cause jeopardy for your success at it. So copying or cutting and pasting from another person's work from any resource and submitting it as your own. That's the obvious plagiarism responsibility you have to be careful of. Also, please watch the paraphrasing use of other parts of works. And if you notice, I highlight the word images. If you're taking an image from someplace else, that is fine as long as you cite it and give credit to where you got it from. And as we all know at this point, Google is not the source of the image. Google searches the images for you. You have to click on them and get the actual web address they're from. So please make sure anything that you're putting on that is not yours is properly cited. And that goes to stuff you've already shared or published. So, make sure you reference anything that is already done. So what do scientific posters generally look like? So layouts, types of mountings. I always like to share this little font story too. If you notice, I lay out my fonts very specifically between the serifs and the sans serif fonts. Um, serif fonts are fonts that have little hooks on the end of them, so I'm not sure if my mouse will be visible to you. You see it has these little hooks on them with these little balls. These are serifs. And serifs tend to be harder to read. However, they have an attractiveness to them that people tend to like. So when I create posters, when I create presentations, I usually do my titles um, in serif fonts, and I do my content in sans serif fonts. Makes them easier to use. It's also important to consider color and usage. The blues are the most popular because they tend to be the easiest to read. Just looking at the screen here, we've got the advantage of the actual screen we're looking at directly, and even yellow in this case looks hard to read a little bit. And I would suggest to you that if you're ever displaying on a presentation screen, yellow is like nearly impossible to see. So is red. They wash out terribly invisibly. So, stick to the blues and the greens. They tend to be easiest on the eyes, easiest to see. The serif fonts people can read quicker and clearer. I got some older style posters that I'm showing here. But the reason I want to talk about this is, you have to start with a title, and titles should be able to stand alone on your visual display. And so whether you're setting yourself up for a JSH oral presentation, or you're starting off with a poster presentation, be clear about your title. Cutesy titles just don't work well. The people who are evaluating you, they're practicing scientists and engineers. They are having an expectation that you do things the way they do things. So the title is really important. Make sure they're descriptive and engage the viewer. It should convey information. And, and very often, titles are viewed separate from the actual projects themselves. So for us, at the Connecticut Science and Engineering Fair, we have the title list that is presented forward to the judges, where they're going to get ideas about what they want to judge and what they want to see. JSHS has a program. Your title is in the program book. And then the next layer is that abstract. But the titles are really important. So what we're going to do, we're going to actually do a little activity right now with everyone. And this requires you to use your chat feature. So make sure your chat window is open. And what I'm going to do is I'm going to share with you two titles from the fair. And what you're going to do is you're going to look at these titles side by side and decide how the judges would score these titles. Now, at the Connecticut Science and Engineering Fair, your project will be scored in the preliminary judging round in 3 categories. You'll either be an honors or a 1, first honors. That's usually about the top quartile of the fair. And then we do our second honors, which is about the middle 2 sections. And then we have third honors, which is the bottom third. So I'm going to show you a title. When you see the title, your job is to decide whether you think it is a 1, the very best, a 2 in the middle, or 3 more at the bottom. And there'll be 2 titles, so you can do a compare and contrast type of thing as well. So when you see them, put into the chat what you think the scores are. So you can just like 1, 2, or 2, 1, 3, 1, whatever works for you. And then we'll take a little look and see how that looks for everyone to see. All right, so we'll go to the next slide. Okay. So 2 sets of projects, food calories, and intragenic competition between bioluminescent dinoflagellates. I'm not sure. I can actually see the chat window while this is happening. Oh, there. Oh, I'm seeing them pop up. Okay. So go ahead and it's in 3 and 1. So lots of 3s and 1s. Now, I think what's one of the amazing things that happens in this process when we share these things is that you're just seeing titles, and there's a poster that gets judged, and these numbers are determined from the judging of the posters. So let's go over here and let's take a look. There we go. So the first one was a 3, and the first one was a 1. Let's try another one. Fabrication of a flexible, tunable, color-changing skin using magnetically responsive Fe3O4 photonic crystal structures, and how robotic facial features affect the ability to attend to and recall movement patterns. Go ahead and vote now. So we're seeing lots of 1s for the first one and 2s for the second one. Mr. Erickson's not a fan of either one of these. Okay, let's see what we got. Look at that. You guys, just by reading titles, are evaluating projects the same way that the judges would evaluate them if they did all of the parts. Hydroharmonics, mathematics behind music and the frequency of musical notes in water. And 2, how geometric and material effects the decibels produce. Seeing lots of 2s, some 2, 3s coming up. If you notice, there's numbers on the left and right of some of you are putting the numbers in. Those were projects that were sitting right next to each other in the fair. When I went through and created this, I said, let me just take 1, 2 right next to each other because that tells an interesting story just where they are. Okay, that was a 2 and a 3. Okay. And the natural antibiotics, garlic versus onion, the correlation between environmental chitinase activities and asthma severity.
Frank, while people are doing them, one student asked, why was that one a 2? And I'm assuming that's after judging that.
Yeah, absolutely. It's after judging. So the judges review the so you're judging just titles right now. However, the judges are judging the whole kit and caboodle. They're looking at the title, they're looking at the content of the poster. And so when we consider a 2 versus a 3 versus a 1, that's based on judges' evaluation on the criteria that is presented. So experimental design, creativity, the presentation in some cases, how the student presented, the idea development in the process, the technical aspects of the way you did your work. Those are the characteristics that go into the judging process. We have for students that are participating in our fair, I did send out a message a week or 2 ago, which specifies all of the rules. It was a whole book, and it has the judging criteria right in it, spells it out for you so you know exactly what we're judging on. this is a 3 and a 2 for that one. So again, super accurate on the part of the students. So great job, everybody. So you can tell the importance of a title in the process. You know, that is really important. Initial impressions do a lot to the level of your success. So make sure you really focus on the important components of communicating effectively. And you know, we're talking in verbal, oral, and written form. So what's typical on a scientific poster? There's usually some sort of purpose, some sort of abstract that's short and concise. Make sure the font size is readable. What is your problem? What did you do? What are the results? And make sure there's some introductory material. When I talk about introductory material, you're doing some background research uh, that provides the reader on, takes the reader or the listener on a journey, and that journey takes you to this aha moment. Of course, you're taking this broad idea, concept, you're giving some background, and you're taking the person on a journey so that at some point they say, of course, this project makes so much sense. I totally understand where the student has come from, why they took this information, and it led them to this place, this time, and this place to share some background information. I will comment, the introductory material in oral presentations can sometimes be a trap for some students. And the trap is they spend so much time on the introductory material that they leave too little time to talk about what they did and what their results were and what they think about the results. So, excuse me, as you plan your talks or you plan your posters, don't overemphasize the introductory material for the sake of making sure you have enough time to talk about what you did and what happened and what it all means. That is a key point. If someone's asking if you should include the abstract in full paragraph form or should you summarize in bullet, I would say for an abstract, that should be written in paragraph form. Other components, you know, you can certainly consider bullets. Introductory material can be bulleted in some sense. Often conclusions can be bulleted for summarization. The abstract, though, is telling your story. You know, what was the question? What did I do? What was the question? What did I do? What were the results? What does it mean in, you know, 200 words or so? And that's a story, and I think that story is served best in written form. Okay? So make sure your real estate on your poster is got some sort of sequential order to it. Uh, People read from top left to bottom right. Make sure it's organized in such a way. And tell a brief story of a student I worked with, probably about 10, 12 years ago. And she was a JSHS oral presenter as well as a Connecticut Science and Engineering Fair project presenter. And you know, I wasn't her mentor for it, but I did give her some feedback and advice in the process. I had worked with her in previous years. And she had this really wonderful idea when neural networks and AI was really kind of in its infancy, and she did a presentation for the Junior Science and Humanities Symposium and was the overall winner for the JSHS. And then the following week was the Connecticut Science and Engineering Fair, and she brought me her poster to look at. And I looked at this poster, and it was not organized in a logical, sequential way. So she had done amazing work, and that amazing work had been recognized. But at that time, the fair was judging posters alone before they brought students to it. And you couldn't make heads or tails of the story because it was out of order and it was disorganizing. And she didn't even make the finals at the Connecticut Science and Engineering Fair, mainly because of the organizational or lack of organizational aspects of her poster. So please be really clean in terms of the way you design those posters and make sure they tell a story. It should be obvious to the person looking at it where the flow is and where it goes. Okay, so there's a question out there right now that says, does including the abstract apply to both the Connecticut Science and Engineering Fair and the JSHS? Yeah, yes it does, but you're not going to put your abstract on a slide in an oral presentation. So your abstract will read with your research report that it's submitted separately for the JSHS, and the abstract is published separately. Connecticut Science and Engineering Fair, the abstracts are published, and they should also be included on the poster. I think text to a minimum and graphics are key in this. Let's see where we're going. Okay, so visuals, keep them simple, cite them, and make sure variables are clear on any graphs and tables you include. I do say tables report data, graphs summarize and interpret trends. I think that's really important. I always think you waste real estate if you give me a table and then you give me the exact same data in a graphical format. You know, think about what message you're trying to convey, and also be careful with the way you summarize data. Posters should be in landscape, not portrait form. The reason they should be in landscape, not portrait form, is because the people evaluating you are most likely doing it on a computer. They're not doing it on a cell phone. So if it's in landscape form, we're going to be able to scroll and move around that poster more seamlessly than if it's in a portrait form. Let's take a look at this idea of summarizing data. This is some older data from a student I worked with many years ago. He was working with mummichog fish. Mummichogs are estuarine fish that tend to live in salt marshes, and they are excellent bioindicators of health and water quality. And so one of the things that the student was doing, he was looking at mass versus length of the fish in order to get it was a kind of a layered project where he took some gross anatomy features, came down, all the way down to liver enzyme activity. So there were many aspects of it. So one of the aspects, the initial gross anatomy was looking at mass and length. And this is the raw data. And I think these are terrible graphs. I would never recommend anyone putting something like this up. Because what does it tell you? Like you look and said, oh, kid looked at about 65 fish. Whip-de-doo. I don't see any relationships. I don't see any summarizing of any trends. This is not an effective graph to communicate much of anything, except that there was a decent sample size. However, if we look at the relationship between mass and length in this way, we can look for trends and patterns, and we get an equation of a power regression of the equation. It tells a slightly different story, and it shows a pattern and predictability of the pattern. So so consider the way you showcase data. And as you start wrapping up, you have conclusions. Make sure they're simple and clear, bullets. Don't forget the error analysis and limitations. And I think this goes back to the limitations, I think, is a really critical one for judges. And the reason it's a critical one for judges is back to Joy's point, you know where your lane is. You stay in your lane. And so we recognize, those evaluating projects totally recognize that the projects are conducted by students, and they're not solving or coming up with a cure for cancer, but there might be a small component of cancer-based research that they're working on. So when students are able to clearly identify what the limitations of their projects are, I think that tells a really powerful story, and it's very convincing to your evaluators that you really have a great sense of your project. Don't forget to do the error analysis too. How accurate and precise do you think your measurements were? And then on the scientific poster, I think references are always a good thing to include, so it gives some sense. I'm never really convinced on the oral presentations, and maybe someone will give a different opinion on this, but some students put their references on the oral presentations, but no one ever gets to look at them because students go and click, 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 these are my references, and no one actually looks at them and reads them. So I'm not really convinced that they're an effective thing to put on an oral presentation. However, on a poster presentation where someone's going to spend some time looking at it, I think that's a more effective place to put them. I do have some examples for you that I want to share. Some of them, I'm assuming most of you, if you're doing a poster presentation, you're going to do a digital poster. You're not going to make a physical poster. So you're going to have a single slide, either made in PowerPoint or Google Slides. that you're going to manipulate and put information on, our judges have the ability to zoom in and zoom out of your poster so they can see the key information and the key things that they want to see. So let's just look at something that wastes a lot of real estate. So here's a project that has a lot of information on it. You'll notice the whole thing is in serif fonts, hard to read. There's all this wasted space on here. Data is fairly limited uh, on the project. Notice that references, which tend to be something at the end of a project, are on the left. So you know how is the story flowing from left to right? Not as effective. So you know, consider how you can effectively do it, because there's a lot of great information in this poster. I mean, you can see procedures and there's a lot of introductory material, but it's hard to actually get a sense of what's going on in this poster because the visuals don't effectively communicate what the student was getting at. This is a project that went to the International Science and Engineering Fair a number of years ago. I think this one was made in PowerPoint, and it has that flow that we've been talking about, visualizations that help tell the story, some enhanced introductory graphics that tell the story. And this is actually getting into some of the, and then a graph. Again, this is hard to see on the view I'm showing you right now, but you can see it's there. Data with a trend line. It's not a line, so it's not a linear regression. And there's an equation here that you're not really able to see, but if you were being judged, you can get in, and if you were judging, I should say, not being judged, you can get in and see that, and then some additional discussions and references present. This is another one that went to the International Science and Engineering Fair, and I think this one actually won the Google Science Fair when that was in operation. So this was the overall winner of the Google Science Fair. This was back when the Ebola outbreaks were happening. And so as a methodology, but again, there's a summary, what the goals are, how things were made, and then a lot of data, a lot of rich, robust data talking about, I mean, I'm not going through specifically what's happening, but you can actually look at this and say, oh, I can see like a story emerging, it's a model, and then what the design looks like. So we've got the design, really great titles to help explain conclusions. This one actually didn't, include references, but that's okay. That's what the student chose to do. So practice and prepare. That's what's key. Anyone who will listen, practice setting it up and know where things are. Practice a 2 to 4 minute introduction. Practice answering questions. And if you're going someplace to do it, make sure you have the stuff you need before you leave home. I know before I started my presentation today, I went through my slides, made sure I was happy with everything. I put a glass of water on the side in case I dried out while I was talking. I know we're going to be doing some feedback to students, so I made sure I had some paper and a pen ready to go. I set myself up in a space where I thought the background looked decent, so I wasn't getting terrible reflections. I know we got some good natural light coming through the window. I don't have lights on right now. I'm thinking about all of those things. When you do the Connecticut Science and Engineering Fair for preliminary judging, you have 10 minutes. 10 minutes includes your presentation and your question and answers. That's a 10-minute window, which is not a long time. You are permitted to upload a short video in support. You'll have your poster, which gets judged separately. If you put a research paper up, that gets judged separately. So think about what you want to do and what you want to talk. Last year, we had a rule against using slides, but this year we are allowing screen sharing and the use of slides. So if you want to have some slides to highlight information, that is totally acceptable, but think about the timeline. JSHS, you're going to talk for 12 minutes, start to finish, then questions and answer. Connecticut Science and Engineering Fair, 10-minute window, have to include question and answer time. So you don't want to talk for 9 minutes and then leave a minute for questions and answers, because that's not going to give you an opportunity to showcase what you really know. And like Joy said, that's where the judges really evaluate your projects and the way you answer your questions. For us, if you make it to finalist judging, that'll be a 15-minute window. So you'll have a little more time at that point. Okay? Be enthusiastic, engage your audience. You know, there's time for live interaction on all those things. And don't forget to answer questions and do the questions as Ms. Erickson has indicated. So I'm going to stop there. I don't know if there are any other questions. I stopped looking at the chat. So let's see if there are any new questions that came up. Okay. Okay. I don't know if students have any questions right now they want to ask before we move on to the pitch portion of what we're doing today. Let me stop sharing my screen. Get everyone else back.
Thank you very much, Dr. LaBanca. Julia has been assigning people to breakout rooms behind the scenes. We're going to do a couple of practice pitches here, one from Joy, one from Dr. LaBanca before we go into our breakout rooms. So we can move on to, we're looking for a volunteer, a very brave volunteer, a couple of them to start off the workshop so we can see what we're going to be doing in the breakout rooms. We are going to have only about 3 or 4, let's say 3 minutes per person, assuming everybody wants to do their 1-minute pitch and get feedback from the team in your room. And so that would be a 1-minute pitch, and then you'll have 2 or 3 minutes of feedback, and the alumni in the room will help with timekeeping and making sure everybody has a chance who wants one. And then once you're all done in your room, you'll be coming back to the main room. There's going to be a little red door on the bottom of your screen to get you back to the main room. But first, do we have a volunteer? You can unmute yourself to volunteer, and either Joy or Dr. LaBanca will, or both, will take this first one.
Come on, who's ready to go?
By the way, this is the best place to get the feedback because you get the 2 of us doing the
Yes.
feedback for you, or the 3 of us, if Dr. Knight wants to join us too and give some feedback. Whereas once you get into the breakout rooms, it'll be a smaller group and you'll just get the opinion of that one person.
Yeah.
Okay, Melinda's volunteering. Melinda, you can unmute yourself and go.
Okay, let me just get my timer. Okay, I'm going to start in 3, 2, 1. So the numbers 6, 3, 2, 2, 1, and 2. What do these all have in common? What this has in common is my research project. My research project analyzes the 6th leading cause of death within the United States, which is Alzheimer's disease. And it analyzes 3 groups: cognitively normal, which is the control group. My 2 experimental groups are mild cognitive impairment, which is a precursor to Alzheimer's, and people with early Alzheimer's disease is my last group. And I analyzed 2 variables, DTI and SV2A. So if you think of a neuron, you have your cell body on one side, and then you have an axon connecting the cell body to dendrites. And basically, the cell body, or the axon, carries the electrical impulses across neurons. And this acts as kind of like a copper wire on the inside, or as the conductor to let the electrical impulses travel through. And then the white matter on the outside acts as an insulator. So DTI basically measures how damaged the white matter is, or how damaged the insulation is. And then the SV2A is synaptic density, which means how many synapses are within the neurons, or how many connections are there in the brain. And if there are less neurons, then there are less synapses. So in Alzheimer's disease, there is neuron death. So if there's less synapses, then you know how far in the Alzheimer's process they are. And within my study, I basically took 2 brain regions, the entorhinal cortex and the precuneus, which are known to be where Alzheimer's disease starts. And I took the synaptic density and correlated that with the DTI measures of every single white matter pathway within the brain. And I came out to find that the cingulum frontal parietal tract was the white matter tract that was the most significantly correlated with these 2 synaptic density measures. And if you graph this on a graph, you have on the x-axis the length of the white matter tract, on the y-axis the DTI measure. And you can see the fluctuations of the DTI measure across this tract. And when you see this graph, you see that there's a significant gap between each of the lines for each group. And this has two impacts, or has two meanings really. So with this, you can use it to diagnose where the individual is on the Alzheimer's disease spectrum based on their location on the graph. And this method could also be applied to different biomarkers in order to determine how these biomarkers are affected over the course of the disease progression. Thank you.
Okay, thank you very much. So I have a question for you. Well,
Yeah.
You made me want to ask you questions, which is good.
Mhm.
So you're doing a lot of these things. I'm assuming you should say where you got some of these materials, but I'm assuming you're working with slides given to you by someone,
Mhm.
and it's slides of these areas. And are they live or are they fixed?
So so these are, I'm taking this from MRI images. So
Okay.
basically if people,
So you worked with somebody to get the images. You're not
yes,
working with, you're working with a computer image that you got.
yes.
That's kind of important. I'm trying to, did you say you were doing it with MRIs and I missed that?
Well, no, I didn't, sorry.
Okay.
Yeah.
That's okay. That's okay. I work with brains a lot.
Yeah.
So, I was thinking to myself, how is she doing this? Brains are the hardest thing to get.
Mhm. Yeah.
So, um, it's a very complicated thing that you're doing. And I think that you explained it pretty well, but there were places where I was trying to follow and got a little bit lost. So
Mhm.
slow down your speech
Okay.
when you're talking so that people don't get so lost. And you talked for 2 minutes and 31 seconds. So it wasn't, you went way over the limit. So that's the thing to pay attention. Are you doing a poster
Yes.
and for science fair?
For JSHS.
For JSHS. So you'll have a limited amount of time
Mhm.
to talk before they ask their questions. I think it's, the total time is 10 minutes, Ellen, that they get with questions that on Sunday,
Are we
27.
talking about posters?
Yep.
I believe it's 3 and 4, 7 minutes.
Yep. So you only get 3 minutes and you almost used your 3 minutes today.
Mhm.
So think about what's the most important thing to say and practice. But I know you didn't get to practice today, but that's my feedback.
Yeah. And I think, I liked that you started with a hook. You gave some numbers and you gave this hook. So now you've piqued my curiosity basically in the first couple of sentences. Oh, now I'm listening for specific things. So now I have a framework in my head, but I'm trying to listen and hear about specific things. You did get, when you started talking about DTI, and then you gave another acronym, SVA or something like that.
Mhm.
And I wasn't quite sure what that meant. So DTI, comma, just a little phrase to
Okay.
help clarify would be very helpful to me as well. And I also agree with Joy. If this was MRI imaging, that was really kind of important, because initially I'm saying, oh, I wonder if she's doing some big data set, and then as you're talking more, I'm saying, no, that's not what it is. That's not a big data set thing. What is it that we're actually looking at? And I was thinking the same thing. Is it slides we're looking at?
Okay.
So just giving that clarification to the methodology. Again, I think, to my point that I made earlier, you gave this introductory material,
Mhm.
it took away from the opportunity to talk about more of what you did. And
Okay.
so some of the methodology would have been helpful to hear about that. You can always reference, once you get to the questions, you
Mhm.
can always reference back to stuff that might be valuable for the person to hear about.
Okay.
And giving acronyms before you give what they mean can
Okay.
be confusing. I did the same as Frank did. So, okay.
Mhm.
But I hope this feedback will help you prepare for that 3 minutes.
And that was a great job, Melinda, and thank you for taking the risk to do that for us.
Thank you.
I agree. Thanks, Melinda. Who's up next? I don't know if you didn't realize it, Melinda, but your camera wasn't on. At least I can't see you. That might have been intentional.
Oh, sorry.
That's okay.
I think with our limited time, we should break into breakout rooms.
Okay, all
But
right.
Lauren's hand was up, so Lauren volunteered. So we could do Lauren. Hey, unmute Lauren and go for it.
Turn your camera on and unmute Lauren.
Is my camera on?
Yes.
Yes.
Okay. Hi, everybody. I'm Lauren Marzi from Canton, Connecticut. In my hometown, I've recently experienced firsthand dramatic changes to the seasons in the Northeast, and I've seen very abnormal rainfall patterns in the past seasons. And I was inspired to investigate the extent to which climate change has impacted the intensity and timing of precipitation in the Northeast in the last 20 years. So I conducted 12 two-tailed match pair t-tests, one for each month of the year, from a random sample of National Weather Service locations, which, if you're not aware, National Weather Service is a department under the National Oceanic and Atmospheric Administration. I found 9 of these months to have significant changes in total precipitation from 2000 to 2020, while the August, November, and February t-tests were not found to be significant. I also calculated the average rate of change of 29 randomly selected National Weather Service locations, and I found this average rate of change to be 22.37% positive increase in yearly precipitation, which is definitely a significant increase in precipitation over the last 20 years. While the National Weather Service data did provide a very wide pool of data for my research to be conducted, I found many of the locations to surprisingly not be complete and have many missing data entries over the years, which was an unforeseen limitation to my research. In the end, precipitation is significantly changing in the Northeastern United States on a rapid timescale. And if extrapolated to the greater US, these findings support that precipitation will continue to rise to further critical levels. Thank you.
Excellent. You stayed within the time limit. Yay. All right. Lauren, I'd like the hook that you had at the beginning, and you told us where you got your data, and you either had it together or the learning curve is increasing as we go through these. So I think that you did a really great job. And that's all I'm going to say now is that was a really good pitch. And then you'll have more time when you get to your presentation. So
Thank you.
I think the one thing I would recommend you think about in terms of your results is you said there was a significant difference. Which is great. Okay, so 9 months, significant difference. But you didn't tell me what the difference was. So I didn't know if you were talking about decrease or increase until really the last sentence, I think, where you said it was a rise. So just explaining the results a little more, I think, would be valuable. So instead of just that there's significant difference in the t-tests, where is the difference and how is it occurring? I mean, that's just a couple words, basically, and it provides a clarification level that I think would be really good. Not everyone might know what paired sample t-tests are, so you might want to talk about the significance values you selected, if you used a Bonferroni correction or anything like that because you did so many t-tests. So just something to consider in the process, just to specify, since it is a statistical analysis project.
okay, we're ready to move. Awesome.
Good job, Lauren.
Okay, so I am going to be sending everyone to the pre-populated breakout sessions. This was done divided by 4 yesterday, but now just because of attrition, it looks like there's double the number of people in Dr. Knight's room than there is in Dr. LeBlanca's room. So when you finish in your room, please come back to the main room. And if we can see that, oh, Dr. LeBlanc is now available, then we'll probably go into Brittany's, Dr. Knight's room and just ask or reassign, or we'll just do something so people can hopefully finish around the same time. If someone ended up in your room who you didn't expect on your list, our team members here who are kind of taking attendance, it's okay, just go with it. Anybody can be in any room, really. We were just trying to divide up. Julia, is there anything else we need to say before I enable the breakout sessions?
I just want to ask question. How much time do we want to spend in the breakout rooms, and when do we want everyone back?
Well, we're supposed to end at 11:30. So
Yeah.
if you do some quick math, there's only about 2 minutes per person in Dr. Knight's room, maybe 3 minutes or more for Dr. LeBlanca's room. But I'm not sure that everybody is going to want to go today. We did ask you to prepare, and this is an opportunity for you, but we're not going to twist any arms. So let's try to be done by 11:30. Does that sound all right?
That's fine. I didn't know if you want this like 11:25 or something like that.
Yeah, I'm not sure we have time.
All right,
So
let's go.
let's stick with 11:30. Okay, here we go, folks. Let's see. So we're starting.
I did just leave myself in the main room so that I could be moved later.
Okay, but you're the authorized adult in that room.
Yep, I will pop in as soon as we know that we're okay here. I'll go now.
Okay, thank you. Okay, Joy.
Yeah, we could start. What we want to do, I will say 3 names. That's the first 3 people, and then I will tell the next person you're on deck. So right now we're going to start with Alexandra, then after her, Anna, then Avery, then Benjamin, then Jason, Junyu, Naomi, Prateeth, Stella, and William. And we want you to stick to the 1 minute. And I don't know how to say your name. Ezzy?
Easy. Easy.
Easy. I just say easy. Easy's
Yeah.
good at time, and he's good at timing. So you get 1 minute to speak, and then we will give you 30-second. Easy, you're going to give a feedback, yes? Or you're just going to time?
You can give the feedback. It's okay, so that won't take time from them.
Okay.
I will just time and I'll give them one in maybe 30 seconds.
Okay.
Yeah.
Let's go. Okay. So.
Yeah, and I have to say, people may not be looking at the chat if they're presenting. So I think if you can just pop in with your voice, that might help them. Just very briefly and subtly. Yeah.
Okay. Anna,
We'll do that.
Anna, are you ready to unmute and share your face with us? Yes, Anna?
Okay. Yeah, sorry. Can you
Okay.
see me?
Yes, we can.
Perfect.
You may begin.
All right. My research addresses the all too common side effect of drug-induced kidney toxicity and ultimately kidney failure. It's a major concern for pharmaceutical companies and extremely dangerous for the consumer. So the reason so many medications cause nephrotoxicity is found at the cellular level because cellular processes are disturbed. My research focuses on endoplasmic reticulum or ER stress, which disturbs normal protein folding functions, often leading in apoptosis of the cell, and on the large scale, it leads to kidney failure. So in my research, I developed a chaperone nanoparticle complex, which when jointly delivered with a nephrotoxic medication, it mitigates the drug's adverse effects so that only the therapeutic effects are really beneficiary from. So the gold nanoparticles I used are for transmembrane transport, and then I tested 2 variations of this chaperone, a protein and a chemical chaperone. And the chemical chaperone was found to be more successful.
Okay.
And
That's your
produce more
time.
results.
All
Sorry.
right.
Yeah. Thank you.
That's okay. I really love this topic, and you have a lot to share. I think your introduction was very good because we knew exactly what you were doing and why you were doing it. And you're trying to protect the kidneys from this disaster.
Yeah, that's right.
And that's really important, and I'm really excited about what you're doing to prevent it. Is there anything that can be done to cure any kidney function once this happens? Is there any coming back?
So it's not exactly a cure. It's more, as you're delivering the medication, you simultaneously deliver this complex, and it
Right.
kind of aids in the recovery of the individual kidney cells, almost as the drugs, your stress capabilities are unfolding.
So that's great. And you keep that in mind, that what you're doing is trying to, two things are going, you called it a companion. So I did kind of get that.
Okay.
So that was very good. Very nicely done.
Thank you. I appreciate that.
Just the right speed. Okay.
Thank you.
Next. Did you guys remember who I said was next? Benjamin, can you share your screen? And I'm going to say at this time, Jason, share your screen as well, but don't unmute yet. Okay, Benjamin, you may begin as soon as you unmute.
Can you hear me? Sorry.
Yes.
All right. Hello, my name is Benjamin Pursley, and I'll be speaking about the use of prime editing in iPSCs to correct and induce the mutation of cystic fibrosis. Now, what are iPSCs? iPSCs stand for induced pluripotent stem cells. Essentially, we take fibroblasts from the skin, and using sendai-viral transduction, we reprogram them to be pluripotent and have the properties of stem cells, which can then differentiate into any cell type. Then, we used prime editing, a new gene editing technology similar to CRISPR. However, prime editing employs single-stranded breaks, nicking only one of the bands, as opposed to the double-stranded breaks of CRISPR, which causes less cell death and off-target mutations. So, we use this technology in iPSCs. One set of wild-type cells, which we attempted to induce the mutation in the iPSCs, and one group of cells we obtained from patients with cystic fibrosis, and then we use the prime editing to correct this mutation. And we saw a rather low.
Time is up.
All right.
Just so that you get a feel for it. That's 1 minute.
Yep.
A lot of big acronyms that you're using. I understand that. I'm a biologist, and that happens. So make sure to define these things and then find a simple word to use in its place if you can, rather than saying that big mouthful all the time. You can start out. The main thing is, what disease did you work on? And you found a mutation in that cell. And then that mutation in the cell, which we call blah, 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 and I will call the mutation during this talk, so that people know it's a mutation. When you start saying those words, our brains panic and we go, oh my gosh, what's he talking about? Okay, been there, done that. Actually, when we first did this workshop, I used to do a 1 minute introduction using all my big buzzwords I could find. And we're trying to get you guys not to use big buzzwords. We're trying to get you to use simple language, define it, and then simple language again, so that we know what you're talking about. Okay. I may have gotten a clue of what you talked about, but every time you said the big letters, my mind kind of went, whoa, 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 So we want to stop that whoa, 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 because you only have 3 minutes, and talk in more generalities and simpler words as substitute. Okay. I just went to a talk and the guy said, I'm going to tell you how to self-talk. And then he described what that meant. And then I'm going to tell you how to, support. And then he'd tell you what he was talking about. So you see how that works? You use a simple word that everybody uses. I taught STEM from preschool to graduate school, and I had to find languages to meet everything. So that's what you need to do too. Okay, Jason, you are next. And Ma, you can share your screen now.
Yeah, can you see me?
Yes, we can. We can see you and hear you. Go for it.
Okay, so a question frequently asked when the pandemic seemed to be coming to an end is how the vaccination, changed the number of COVID cases and the extent of its ability to suppress infection. So I conducted a study of how holidays caused a spike of COVID in 2020, and I also continued to wonder how the post-vaccination infection rate differed this year in 2020 when I conducted my study from that of 2020. And I had a few goals. So first, I wanted to prove that the vaccination was effective in reducing cases and deaths. and I wanted to find how the post-holiday surge of cases differed from 2020 to 2021. And I also wanted to see how the vaccine played a role in that post-holiday surge. So I did this by downloading data from the CDC and the Johns Hopkins databases and used Excel pivot tables to analyze it. And I found that among 10,000 people, every additional 100 full vaccinations prevented 8 infections. And out of the state's population, every 1% increase in people fully vaccinated prevented 35 deaths per 1 million people. And this data really proved to me that the vaccination was effective in reducing cases and deaths from COVID. So
Thanks.
now I wanted to focus.
That's the time. That's how fast 1 minute is. So
Oh, sorry, I thought we had 2 minutes.
we're giving 1 minute because of circumstances, which is very difficult. So you did a nice job. I understood exactly what you were looking at and what you were doing. And I was waiting for you to say, was there a difference? Was there a difference? When you have an elevator pitch, get right to that difference. And you did get to it within the minute. Then you said, and now I want to do this. That's really great. You talked at a good speed. Your voice was clear, and I understood exactly what you were doing. So, infection and deaths. Very clear. Okay. Excellent job, Jason. Okay, Junyu, can you share your face and unmute?
Yes, can you see me?
Yes?
Okay.
All right, if you are ready, go.
Okay, so last summer I started researching prostate cancer. It is the second most common cancer and the fifth leading cause of cancer deaths among men. So this is urgent to find reliable prognostic molecular biomarkers in prostate cancer for prognosis improvement. I searched for differentially expressed genes of prostate cancer using dataset from GEO. Secondly, I used OrClan to perform prognostic analysis on the differentially expressed genes. It allows me to search for significant prognostic genes from the DEGs. Finally, I analyze single-cell dataset in R programming. We cluster, then identify cell type, then perform single-cell analysis on the prognostic genes, analyze their cell expression and significance in the tumor microenvironment. Eventually, 7 differentially expressed genes were identified as prognostic genes. They were expressed in prostate cancer epithelial cells, but were also expressed in some tumor microenvironment. Overall, they are mainly related to the biological behavior of the tumor itself. And these 7 genes have never been reported before. They are novel molecular biomarkers and maybe, oh, sorry, time is up.
Okay, time is up. There you go. So now you know what 1 minute is, and it's a lot to put in. You will need to practice saying what you're saying and look for, again, you need to practice so that you're not reading and that you can put in your enthusiasm and your excitement for your project. So you're trying to get better diagnosis for prostate cancer. And also that value statement, diagnosis for prostate cancer now is not very good. And a lot of people have the surgery because they don't want to think about it anymore. They tell me I might have prostate cancer. Okay, let's just do the surgery. So that's an important thing. You're doing a very important study, and if they can put these markers through that model, we never got to it. How good is your model? We trained our model. So remember that thing that Dr. Labanca said, not to include your abstract when you're talking, but when you're doing that 1 minute talk, you want to give them the bullet points. Don't keep us in suspense. Was it successful with what you did? Okay.
Yes.
Now we have Naomi Park with Prateeth Kurup. And I don't know if I'm massacring your names up on deck. So, Naomi, can you share your screen, unmute so we can start?
Can you guys see me?
I can't. Oh, there you are.
Okay.
Okay.
All right.
Go for it.
Hello everyone. My name is Naomi Park, and it's so great to meet you all. So every morning, or at least every school day, I'll wake up at around 7 a.m., walk downstairs, and start my day with a nice glass of cold, refreshing water. However, the sad reality is that there are trillions of tons of microplastics in our waters, not only harming the sources we consume, but even more vital aquatic ecosystems. What I actually found a couple months ago was that the Red Sea offers one of the lowest floating plastic loads worldwide due to the abundance of coral on the ocean floor. what researchers found was that actually passive removal of microplastics through adhesion to the coral surface was 40 times higher than active removals through suspension feedings. However, as we all know, coral is vital to ecosystems and the inner workings of many marine habitats. Therefore, killing them for the purpose of microplastic remediation would be extremely counterintuitive. Therefore, I developed an artificial coral sponge that can absorb and effectively remediate these detrimental microplastics in water. I've tested several configurations, and the artificial coral sponge was able to retain roughly 93% of the microplastics within the polluted solution. Thank you.
Okay. Thank you. Nice job. Good introduction. You've practiced, I can tell, which is really awesome. And that sponge and doing, you know, nature maybe can do so much, but we really don't want to kill our coral reefs. So I really liked that topic. So for this exercise, you did an excellent job. Excellent job. Okay, keep practicing. All right. We have next is Prateek. Can you share your screen? And Stella, you are on deck.
Sure.
And we are keeping on track.
Can you hear me?
I can hear you. I can't see you yet.
I can see him.
You can see him? Okay, you start talking and maybe I'll see you.
All right.
Oh, I see
Hi,
you now.
my name is Pratit. My research focused on multiple sclerosis and the role of cell adhesion molecules in allowing white blood cells to traverse the blood-brain barrier and enter the central nervous system. I specifically looked at the molecule ICAM1 and how it breaks down the blood-brain barrier for patients with MS. To conduct this research, I developed a model of the blood-brain barrier using a microfluidic cell platform called an organoplate from the Meadows company. I first formed a gel barrier and seeded it with bovine brain endothelial cells, and then I loaded a medium of white blood cells and into the plate, one set with ICAM1 and one set without, to compare the results. And I found that in trials with ICAM1, that barrier integrity was compromised, while in trials without ICAM1, barrier integrity was retained. So these results show that ICAM1 plays an important role in progressing the disease.
1 minute. You got through a lot. You were speaking very slowly, which is good, and saying things very clearly. And I'm really interested in how you made your blood-brain barrier. Anyways, that's my problem. I'm curious about everything. I worked with blood-brain barriers for many, many years. So this research seems very good. You're going to have to get people up to speed pretty quick. And think about, is there a way you can tell your story about what your purpose is using simpler language to begin with? I understood what you were talking about, and I like that you used the blood-brain barrier. You said it out loud, and you said it very clearly. So I'm not sure, though, a person who was, say, an engineer would understand where you were coming from, but you explained it very well. Very well. Okay, thank you. All right, I think William, no, Stella is next, and William is on deck. And then we will go back to you, Avery, okay?
Can you hear me?
I can hear you. I can see you. All right, Stella, you're ready to go.
Over 10 million people die from cancer annually, and this worldwide issue is becoming increasingly worrisome as cancer prevalence is expected to increase. While chemotherapy and irradiation are available treatments, they are heavily invasive and cancer cells can develop a resistance to these options. Antibody immunotherapy is an up-and-coming treatment option that harnesses the immune system to recognize and kill cancer. Importantly, immunotherapy is non-invasive and develops an immunological memory to fight any cancer reoccurrence. Last summer, at a lab in Brigham Young University, I developed a novel SCFV antibody-mediated immunotherapy against HPRT. An SCFV is just a certain type of antibody, and HPRT is a housekeeping protein with cancer-specific surface presentation that makes it a good candidate for antibody targeting. I selected an SCFV with a high binding affinity to HPRT so that the SCFV could bind reliably and long enough to HPRT in order to incite an immune response. Finding such an SCFV required a method known as yeast surface display, a protein engineering technique that uses magnetic and fluorescent sorting in order to identify.
This up. All right, you're one with, you have obviously practiced, but you've got a mouthful of acronyms going on there, and telling what they are, finding some kind of replacement for them. I used to, I've done everything, I'm telling you, but I have done this type of research where I have my CB1s and my CB2s and the mouse protein and this protein, and they a picture is worth 1,000 words. So make a picture of your cake, of how you're layering these things, and then label them. I really highly recommend you need a picture behind you when you are talking about this. And then once you have your picture, then you can talk about them without filling your mouth with words we don't understand. We know that you're saying something, again, those acronyms, say them at the beginning, but then, call it the target antibody, the target antigen, something like that, the way we find our target antigen, the way we find our target antibody is this way.
Okay.
These are our targets. This is what we're looking for. Those are good words to use, because everybody then goes, oh yes, the target she is looking for. Did she find her target, and was her target effective? That's what they want to know. And what methodology did you use to find that target? And how successful were you at finding these targets and curing this disease? And you say that at the wrap up at the end.
Yeah.
Okay. Next we have William, and I saw you. Have you unmuted, William? Brittany,
Yes.
are you all done? With all your students. Wow. Okay.
All right, so you can hear, sorry, you can hear me, right?
Yes, we can. We can hear you and we can see you. And Avery,
Perfect.
you're on deck.
Should I start now?
Start now.
All right.
With 1 minute.
Hello. My name is William Bernfeld, and today I will be presenting research on the structural determination of novel non-canonical base pairs and mismatches. With the arrival of the COVID-19 virus and its variants, humanity has suffered the destructive power of a global pandemic, the likes of which have not occurred since 1920. With over 4.5 million COVID-19 related deaths worldwide, the scientific community is rushing to find ways to slow the virus. Although viral tests and vaccines have been widely distributed, many tests yield false results, and numerous breakthrough infections are being reported in vaccinated individuals. Thus, we must improve the tools by which we address the pandemic. To address this need, we synthesized a set of 4 novel nucleobase pairs, 2 from purines and pyrimidines, and 2 from pairs of pyrimidines mismatched by transition metal ions to expand the nucleobase language. We used various softwares to form predictive models of our pairs, then running simulations to predict their stability. Upon completion, we assembled the pairs in vitro and fitted them with sticky ends to allow for crystalline self-assembly. Through X-ray diffraction, with phasing and refinement, our findings suggest that these novel, unnatural base pairs are indeed stable. The presence of novel pairs, such as those designed herein, allows
your
research.
time's out. It's only a minute because that's what we did. So far I'm following you, which is really excellent. And yes, I would say it hasn't happened since 1920 because it happened in 1918 and 19. So that was good, and I did understand all that you were saying. And it's going to take a while to get to lots of big words, but I don't know how else to make them smaller. Okay. But you did an excellent job. And I know we said 2 minutes, so it's really hard to go to 1 minute. So excellent job, William. And thank you for your presentations. Okay, Avery, we are ready for your 1 minute presentation.
All right, can you hear me?
Yes.
Okay, so my project is looking at the effects of caffeinated versus decaffeinated green tea in beta amyloid-induced Alzheimer's disease in pond snails. So a lot of the treatments that are available for Alzheimer's disease don't really have a serious long-term effect. So my goal is to try to find a natural way to help reduce the effects of cognitive decline that is present in Alzheimer's disease. By doing that, so to do this, I'm dividing snails into 6 groups and training them to have reduced feeding behavior. So first I'm placing sucrose in a petri dish with the snails, and then after a few seconds, it will be replaced with potassium chloride, which will act as an unconditioned stimulus and reduce the feeding response. Then after training, they will receive caffeinated decaffeinated green tea and then given beta amyloid, which will create the effects of Alzheimer's disease. After a certain amount of time, a memory test is conducted, and I found that the beta amyloid green tea group was most successful, meaning that the group of snails that received beta amyloid and received caffeinated green tea had the most reduced feeding effects and was the
Okay.
most successful.
Excellent. You came back strong, Avery.
Thank you.
That's really amazing. Nicely done. Need to breathe. Don't forget to practice. So yeah.
Okay, so Julia has popped into Mr. Erickson's room, and they're on their second to the last there. We know that Dr. Knight's room is back, Dr. LaBanca's room is back. So if we could just hang out here for 4 minutes, they'll be back with us. Do we have any additional questions from any of the competitors? You can unmute or put it in the chat. Also, I want to say that if you are a JSHS competitor, poster or oral, we'd like you to stay behind so we can practice. You can practice WebEx screen sharing just to make sure you can navigate that. I don't know what platform CSEF is using, but we just want to offer that now so you can feel confident about screen sharing and all that.
We are using Zoom.
Okay.
Okay, Lauren, you have a quick question. Do you want to unmute yourself?
Yeah. Hi guys. I'm not super familiar. This is my first time using Excel for PowerPoint, or excuse me, Microsoft for PowerPoint. And I was wondering if you change the size of it, still using the 4:3 format, is that going to change the quality of the pixels when you upload it as a PDF, or can it be any size within that 4:3 dimensions?
So are you talking specifically for making a poster?
Yes.
So what I generally recommend, and you can do it in PowerPoint or you can do it in Google Slides too. So either way is fine. You know, whatever you're most familiar with is what I would go with for that. Both programs offer the option of changing the size of the box. So you can certainly use it as is in the standard slide format, which is whatever it is, 16:9 or whatever, because that's what the screen's going to look like. The person looking at it is likely going to look at a screen that's that size, so that will work. However, what you'll probably find is like you'll be making really small font sizes, like 2 or 3 or something like that, to get your content in. What I generally recommend is if you go to on both programs, you can go. I might just show you right now. Screen. So if you go to like this is a little bit older, so it's on the 4:3 format. But if you go to the page setup here or on the Google Slides, you can change this to a custom size. So like a poster could be
48 by 36.
48 by 36. And you do 48 by 36, and then we'll just rescale. And this is probably going to. Oh, it actually did already. So that's a 48 by 36 size. Then you can move your content, but what's going to happen is these fonts are going to become huge, right? So like this is now 153 point, but I think a good size then is like 24, 26 is a good content size. So like titles at 36 or 40 or so, and then content 20 to 24, 26. And you can read it, and you can do the same thing. Like if I'm working on something like this, and I put a text box in, let me see if I can do this. Get the screen, a text box in here. Text is small here, and so then I change this because I'm going to make this the right size, like 24 point. Oh no, golly gee, it looks so small I can barely see it. But what I can do is if I'm clicked on the box or near the box, I can do a view and I can do a zoom in, like maybe 400% or something. And now I can see and work in that area. 400 is too close, I guess, in this case. So maybe 200 would be better. And then I can work in my small text box there on that portion of the poster, and then zoom back out to get to the area that I want to see in terms of layout of the whole thing. Sharing screen. I can stop sharing. Please save
Thank
them
you.
in
That makes
PDF
sense.
format
That really
for
clears
us.
it up.
No problem. Make sure you save them in PDF format for us too. Don't give us a PowerPoint. Don't give us a Google slide. Those sometimes get funky on the judge's end. Give them a PDF. That's the required format. At least for us, that's the required format.
Us as well. And Easy just wrote that. Wow.
Any other questions from the presenters? I can see that Mr. Erickson's room is coming back now. And looks like they are back. Okay, that's great. So I hope it went as well in your rooms as it did in the main room. We had some good, not enough time, of course, but really great examples, constructive feedback, and we hope it was helpful to you. So I want to mention a couple of things. One is there is going to be an evaluation of this workshop. I will send you the link probably sometime in the next, I don't know, 24 hours. But please give us your feedback. We want to know, we did things a bit differently this year and we want to know what you think. And so there will be some wrap-up words, I'm sure, by our team members here. But anybody who is JSHS poster competitor or oral competitor, please stay on, and you will have an opportunity to either go to a breakout room or stay in the main room to test WebEx, so you can be confident you know how to share your screen and navigate. Try a couple of things that we'll ask you to do. And you'll just each take a minute. It'll just take 1 minute per person. Okay, so that's my housekeeping.
Okay. Well, I think I heard a lot of great projects. All the science is there. And the biggest word I'm going to say is practice, practice, practice. And that will help you to get better and practice in front of people that don't know anything about what you're talking about. Practice in front of groups, get the jigglies out. And I think that's my takeaway today. Practice.
And I just want to congratulate everybody for joining us today. You took a step that a lot of students are not taking today, and that is getting feedback on your work. And it's like the free feedback from people who evaluate these projects all the time. So I think you can take advantage of the comments that you got, not only that you got directly, but probably what you heard to other people as well, to help shape and create the best presentation. We want you to be as successful as possible, and we can't wait to see you in the coming weeks in March to share this amazing work.
Dr. Knight, any final thoughts as JSHS students stay? Any final thoughts from your perspective?
I'm just really excited for you all. I think you're doing an amazing job, and it's just so wonderful to hear what you've been doing, and I'm just blown away every year, every time I help. So just remember to breathe. And, everyone's just so excited for you, and we just want to hear your story. So good luck as you're preparing, and can't wait to see you the day of.
And one more thank you to the alumni who joined us. And it was just wonderful to have that additional perspective. Some folks who are still in the thick of the research and publishing, and it's great to have you here. So without further ado, it's 11:40. Thank you very much. Joy, I'm going to let you say the actual goodbye, but everybody except Julia and I And the JSHS competitors, poster and oral, is able to go and enjoy your weekend. Hopefully, I know you have a lot of work to do, but everybody else stay to do that WebEx test.
Okay. All right. And thank you, Bob. Bob and I are in the same house. He's just downstairs and I'm upstairs. So thank you, everybody. And you've got this, is what I hear, and breathe. And I'll see you next Sunday if you're in the oral competition for JSHS. Okay. Bye-bye.